Hi everyone. In the given problem statement, we have to find first and last position of an element in an sorted array. So this is here we have to solve this algorithm in big O of log n time complexity. As I keep on saying, whenever you see a big O of log n and you have to do a searching in an array, right? We'll have to use a binary search. So we already are aware of the binary search algorithm, right? So let us take this element 5, 7, 7, 8, 8, 10. Our target is 8. Out here, right, it can have duplicate elements. So our left is going to be 0 for now, and right hand side is going to be 5. So our mid, right, we can be 5 plus 0 double divide by 2, it would be around 2. So current mid, right, is going to be index 2. Now a question might arise, right? Is this mid value, right, is greater than or lesser than the target? It is smaller than the target, right? So our left pointer is going to be increased to mid plus 1. So our left pointer would be at 3. So 5 plus 3 is going to be 4. Is going to be 8. Double divide by 2 is going to be 4. So our mid right is going to be at this position. So once we are at this mid right, so our target is 8 and we are reached to the mid position. So we can assume, right, we got the value. Now we already got the value, but here, right, you have to find the first and last position. So what we can do, right, we are already got the value of index 4. So I can keep on incrementing the index 4 on the right hand side plus 1. Is the value, right, is it is it equal to target? If it's equal to target, right, then from here, right, we can create our own. Let's say now we can say left and right is going to be 4 for both of them. Okay, we increased the right pointer by plus 1 to become 5. Is the 5 equal to 8? It is not. So our right is still going to be 4. Left, we can be left minus 1, which is going to be 3. Is num of 3 is 8, which is true. It is 8. So our left is going to be 3. We are going to decrement it again. L equal to L minus 1, which is 2. So L of 2, right, is 7. It is not equal to 8. So we are not going to decrement it any further and going to break the loop. And the return statement that we're going to do, right, is going to be return of 3 comma 4. That would be our output. So in this way, right, we can solve this problem very, very simply. Now let us jump to the Python solution. So the first thing that we're going to do, right, we are going to create our left and right pointer, or left and right side, which is going to be 0 comma length of nums minus 1. So while our L is less than equal to R, we're going to find the mid. So mid equal to L plus R divided by 2 to get the integer point value. Once you have got that, so if the first thing is that if nums of mid is less than our target, then we can say L equal to mid plus 1. L if nums of mid is greater than the target, then R equal to mid minus 1, and else, right, we found our value. So we can say, but here, right, we have to find the first and last index. So we can create a function def search index, which is going to get our right and left and right value, left and right. So I can say I can call this function, which is going to be return search index of mid, because both of them are going to be the same for now. So now we can check certain conditions. The first thing is that while our left -1 is less than equal to 0 and if nums of L -1 equal to target, then we can say L equal to L -1. In case it's not true, right, we can break. Similarly, we can do for our right side. While R +1 is less than equal to length of nums -1, while if nums of R +1 is equal to target, then we can say R equal to R +1. Else it's no longer possible to go on the right side, so we can break the loop and we can return our first and last index, which is going to be L and R. And similarly we can return it the values, but in case we're not able to find a value, in that case we can return both -1 and -1. Let me run the code. I hope it should work. Let's see. It is giving a wrong answer for a particular value. I made a mistake. If it's greater than equal to 0. As you could see, it's working fine. Let me submit the code. As you could see, the got accepted and it is betting 100% of the submission, and our code is pretty efficient and it gives us the value in big of log n. But after that, try to find the left and right side. You have to do some more iteration. That can take some time, but generally you can say it's big of log n. So our code is pretty efficient. That's all for this video. See you in the next one.